Japan is no stranger to earthquakes. For centuries, the country has lived with the constant awareness that the ground beneath it is never fully still. Yet, even by Japan's standards, the recent surge in seismic activity has reignited deep public anxiety and scientific concern. Strong earthquakes striking both offshore and inland, persistent aftershock sequences, and renewed government advisories have brought back an uncomfortable question many hoped would remain theoretical for decades longer. Is Japan moving closer to another megaquake? In recent weeks, Japan has experienced a series of powerful earthquakes that have caused injuries, infrastructure damage, and widespread disruption. These events have not only tested the country's world-leading disaster preparedness systems, but have also forced scientists to re-examine stress accumulation along some of Earth's most dangerous fault zones. The broader pattern emerging from Japan's seismic landscape has intensified discussions about what may lie ahead. To understand the possibility of a future megaquake, it is essential to examine Japan's recent earthquakes in context, how they occurred, what they revealed about tectonic stress, and why certain regions are now under closer scrutiny than ever before. Today, let's delve into Japan's growing seismic unrest and the unsettling question of whether a megaquake is drawing closer. Don't forget to click on that subscribe button and like this video, as it's the best way to support this channel. Japan sits atop one of the most complex and hazardous tectonic settings on the planet. The country lies at the intersection of four major tectonic plates: the Pacific Plate, the Philippine Sea Plate, the Eurasian Plate, and the North American Plate. These plates do not merely slide past one another. They collide, dive beneath each other, and grind together at varying speeds and angles. Along Japan's eastern coast, the Pacific Plate subducts beneath the Okhotsk microplate at the Japan Trench. This is the same system that produced the catastrophic magnitude 9 Tohoku earthquake and tsunami in 2011. Farther south, the Philippine Sea Plate dives beneath southwestern Japan along the Nankai Trough, a massive offshore fault zone capable of generating earthquakes exceeding magnitude 8. This constant subduction locks enormous amounts of strain into the Earth's crust. Over years, decades, or centuries, stress builds silently. When the locked portions of these faults finally rupture, the energy released can reshape coastlines, generate devastating tsunamis, and alter the course of history. Japan's location ensures that earthquakes are not anomalies, but inevitabilities. What makes the current period particularly concerning is not just the number of earthquakes and their magnitude, but where they are occurring and how they relate to long-recognized seismic gaps. In recent weeks, Japan has been shaken by a series of notable earthquakes that have renewed concerns about rising tectonic stress beneath the country. On December 8th, a magnitude 7.5 earthquake struck offshore near northeastern Honshu and Aomori Prefecture, prompting tsunami warnings and temporary evacuations along parts of the Pacific coast. Although the resulting waves were relatively small, the quake was widely felt and caused injuries, infrastructure disruption, and power outages. Just 4 days later, on December 12th, another strong magnitude 6.9 earthquake occurred in the same offshore region, reinforcing concerns that the area was entering an active seismic phase. These recent events followed earlier major earthquakes, most notably the magnitude 7.6 Noto Peninsula earthquake on January 1, 2024, which devastated parts of central Japan and was followed by hundreds of aftershocks lasting months. Together, these earthquakes highlight how stress continues to migrate through Japan's complex fault systems. Scientifically, this pattern suggests heightened tectonic activity along key plate boundaries. Earthquakes of this scale can subtly alter stress conditions on nearby faults, particularly along major subduction zones such as the Japan Trench. As a result, scientists remain watchful, emphasizing preparedness rather than prediction as Japan moves through this period of elevated seismic unrest. One of the greatest challenges in earthquake science is distinguishing between background seismic noise and meaningful precursors. After a large earthquake, aftershocks are expected and can continue for months or even years. Occasionally, however, what appears to be a standalone earthquake later turns out to have been a foreshock to a much larger event. Japan's experience in 2011 looms large in this regard. 2 days before the magnitude 9 Tohoku earthquake, a strong magnitude 7 class earthquake struck the same general region. At the time, it was treated as a major event in its own right. Only in hindsight did its true significance become clear. This historical lesson has made Japanese scientists cautious. When large earthquakes occur near major subduction zones, they are careful not to dismiss the possibility, however small, that a larger rupture could follow. This caution sometimes manifests in the form of advisories or heightened monitoring rather than definitive warnings. It is important to emphasize that no current scientific method can predict earthquakes with precision. There is no instrument that can say when or where the next megaquake will strike. What scientists can do is estimate probabilities based on long-term patterns, fault behavior, and stress accumulation. The Japan Trench remains one of the most closely watched seismic zones in the world. Even after the immense rupture in 2011, large portions of the subduction interface continue to accumulate stress. Some segments slipped dramatically during that event, while others moved far less than expected. Recent offshore earthquakes near northeastern Japan have raised questions about how stress is redistributing along the trench. While none of these earthquakes alone approach megaquake scale, their locations and mechanisms provide valuable clues about the evolving tectonic environment. One concern is that partial ruptures or clustered earthquakes could transfer stress to neighboring fault segments. If a locked portion of the subduction zone has not ruptured since before modern records, it may still be storing energy capable of producing a very large earthquake. For coastal communities, the implications are profound. Even a slightly smaller megaquake than 2011 could generate powerful tsunamis with little warning, particularly for regions closer to the epicenter. If there is one fault system that consistently dominates discussions of Japan's seismic future, it is the Nankai Trough. Stretching along Japan's southern coast, this subduction zone has a well-documented history of producing magnitude 8+ earthquakes at intervals of roughly 90 to 150 years. According to a 2025 government report, the likelihood of a Nankai Trough megaquake occurring within the next 30 years now stands at an alarming 80%. The consequences of such an event have been extensively modeled. The Japanese Cabinet Office estimates that nearly 300,000 people could die in the worst-case scenario, with more than 1 million displaced and direct economic losses exceeding $1.8 trillion. What makes the Nankai threat so terrifying is not just its size, but its proximity to major population centers. Cities such as Nagoya, Osaka, and Shizuoka lie within the danger zone. Shaking would be intense and prolonged, and the tsunami could easily overwhelm existing seawalls and flood defenses. Furthermore, because the Nankai Trough is divided into multiple segments, there is the possibility of a cascade rupture, in which one segment fails and triggers the rupture of adjacent sections, producing a far more massive quake than a single segment rupture. Faced with a mounting probability of a devastating event, Japan has taken significant steps to strengthen its disaster preparedness. In 2025, the government unveiled a comprehensive update to its national earthquake response strategy. It includes stricter timelines for seismic retrofitting of public buildings, mandatory annual reviews of high-risk regions, improved evacuation routes, and a significant expansion of tsunami shelters along vulnerable coastlines. Schools and workplaces now conduct regular earthquake and tsunami drills, and emergency supply kits are being subsidized in some districts. Early warning systems, already among the best in the world, are being enhanced to deliver faster and more localized alerts. This includes integration with mobile networks to send vibration-triggered notifications to smartphones within seconds of a detected tremor. And yet, despite all technological and institutional advancements, the core dilemma remains. When will the next big one strike? The recent large earthquakes and the intensifying focus on the Nankai Trough all point to a country on edge. But Japan is not paralyzed by this threat. Instead, it is actively rethinking how cities are built, how communities are educated, and how science and public communication must evolve together. Living atop one of the world's most dangerous seismic settings means accepting a future shaped by uncertainty. For Japan, that uncertainty is woven into daily life, policy decisions, and national identity. The ground may shift without warning, but the country's commitment to understanding and preparing for that reality remains unshaken. The probability of a megaquake occurring within the next 30 years remains high, perhaps alarmingly so. But through careful monitoring, strategic planning, and community engagement, Japan continues to push the boundaries of what it means to live safely in an unsafe place. In the end, earthquakes may be unpredictable, but human response need not be. Preparedness, vigilance, and empathy are the best tools Japan has, not just to survive the next megaquake, but to recover from it stronger than before.